It's been a while since I posted any videos because I've been dealing with some health issues. But fortunately, those are largely over, and so I'm able to get back to hobby projects. And this is a good time for that because there's a new 6502 in the house. So you can't really see what this is while it's all encased in bubble wrap. It only just arrived yesterday. So let's open it up and take a look at what we've got. So this will be very familiar to Brits of a certain age, uh, Brits of the same vintage as me. This is the BBC Micro, or BBC microcomputer, which was introduced in 1981 and very common in British schools during the 80s and even into the 90s. This is the Model B. It was originally introduced as a Model A and a Model B. The Model B has 32K of RAM and some other facilities that the Model A did not have. This was also the first computer I ever owned. I had one as a kid. It wasn't as popular as a home computer, more in schools, and also used a lot as control equipment. And you'll see why when we go through the port. So let's just have a quick look at what it's got. One of its unusual features for a 1980s microcomputer is a really good full travel keyboard, which is really nice. And then these are reprogrammable function keys in red along the top. One of the things that makes the machine unusual is its degree of connectivity. So let's have a look at the ports. Along the back here, we have a number of different video output options. So we have RF, what's marked here is UHF out, RF out for an RF modulator for a television. We also have composite video out on this BNC connector, as well as straight RGB. And then RS423 here is basically a version of RS232, but a slightly different spec that allows for longer cables. There's a cassette port for connecting a tape player for loading and saving data. There's an analog input, which is used largely for joysticks, but can be used for other things because it's got the digital to analog converters are available in software. EchoNet was a networking standard. I don't think it's going to be populated on. It's not populated on this machine clearly because there's no a connector here, but the hole for it has been pushed through by prying fingers. But so that's already quite a lot for an 80s computer, especially all those video options, but that's not by any means the end of the story. Down here on the bottom of the computer, we have a whole bunch more ports. So this is for floppy disks. Here's a printer port. This one, which you can see is actually occupied, and we'll see why in a while, is the user port, which is basically 8 pins of GPIO. The 1 megahertz bus is another access point, another parallel bus controlled by the processor and other units. And then this is an interesting one. This one is called Tube. And that's because this machine was actually originally designed as a dual processor machine. And the tube is a mechanism for connecting second processors. At the time, they introduced a 6502 processor, dual, also a Z80 that you could connect to it, and I think a NAT Semi 32016 perhaps. These days, a common extra thing to plug into it is an ARM in the form of a Raspberry Pi, and I might try that. Okay, so that's so much for the outside of the machine. Let's open it up and take a little look inside. To do that, we remove 4 screws. So there's one down here. And then one over here. So there's 2 on the underside, and there's 2 on the back. And then now we've taken those out, the top should just lift off. Let me turn this around. Yep, there we go. The top's lifting off all by itself. Okay, let's see what we've got inside. So this is a 6502 based machine, just like the Apple II and the Commodore 64, and indeed like my home built machine. We've got 32K of RAM, which is up here. Here's the area unpopulated on the board, which would be the EchoNet controller. There are two empty sockets over here, which I think were for a speech synthesizer facility. Um, what else do we have going on that's worth noting? This is a ULA that with the heatsink on it, basically like an early form of FPGA. And that was it did a lot of the logic management for the computer. You can't quite see them here because I haven't removed the keyboard, but when I do remove the keyboard, there's like 5 sockets under here for ROMs. And these are, I think, 16K ROMs or 8K ROMs. Um, the operating system has a very nice mechanism for integrating the ROMs and paging between them, so that you can add ROMs to add extra functionality. What we have in this one is WordWise, which is a word processor. So that's built into, that was an optional extra. It's built into the ROM. Um, the other thing you can see maybe here going on is this board, which is actually an aftermarket, a contemporary edition. That's what was connected to the user port. So this is a mechanism to use this SD card as storage. So we'll also have a ROM for that. And so there's a lot of software on that. The computer was introduced in 1981, as I said. There's a label on here that says 16th of June 1983. I don't know if that's actually the date on the machine. Maybe let's just have a look and see if I can see some date codes. Well, the processor is from the 34th week of 1984. So I suspect our manufacturer date is probably more like 1984, unless the processor's been updated. Most of the other chips say 1983, so it's an 83 or 84 vintage machine. There were a different number of issues for the design of the main board. You can just about see where it says issue 7. Here it's sort of partly obscured by that label. So issue 7 was the last revision of the board. So the first thing I need to do, I'm going to remove the keyboard to do this, is to make some changes to the power supply. I just bought this machine on eBay. It has, I am assured, been recapped, so the power supply has been serviced to get rid of all the. These machines are actually pretty reliable in general. The power supply is the only thing. I mean, obviously it's a 40-year-old computer, so electrolytic caps burn out, and there's a couple of Refa caps in there as well, which have a habit of exploding and releasing pretty acrid and unpleasant smelling smoke. But the other thing, of course, is this was a British computer, which means it was built for British standard voltage of 240 volts AC. I'm using this in the United States, and so I want to run it on 120, the standard US voltage. The power supply was built so that it's switchable. So I just need to reset, desolder, and then resolder a new jumper on a particular part of the board to do that. So I've been reading up a bunch of things on this. I've never actually done this, nor have I seen a video for sure on doing this particular modification, but it should be pretty straightforward. So step 1 will be to release the keyboard. It's held by 2 screws underneath and nuts on top. So that's just a little difficult for me to get to. Okay, that's the keyboard released. I'm going to have to, let's see. That's enough to just move it out the way, which I think is all we need to do. So now we can see the sideways ROM bank is fully populated. So this should be the this one here is the operating system. This one is marked WW, which I think means that's word-wise. That's the word processor, so I was wrong earlier. This one is almost definitely the basic ROM. This one is MMFS, which is the multimedia file system. Actually, no, I think MM stands for something different. But that's the file system that controls the SD card. And then this is the DFS. This is the disk filing system. So if I was to plug in a floppy disk, that's to do that. I suspect that this depends on that as well. So it may be that I can't operate this without that in there as well, but I don't quite know. Okay, so now that that's out the way, I should be able to release the 3 screws on the bottom. I just want to be very careful with this, but maybe just to be on the safe side, I will remove this keyboard connector. And also the speaker connector, which is over here. Move the keyboard entirely out the way. And I said that this had been recapped, and you can see that there's 3 new screws here. So after removing the screws in the washer, I just want to be very careful turning this over because there's nothing holding the power supply in now. But it's still connected to the board, so if it were to fall out, that would be bad. So there are a number of points across the board where we need to disconnect the power supply. I've got it on video partly so I can remember where they all are, but they are actually labeled on the board 0 volts and VCC, so it should be easy to remember afterwards. So these are all 5 volts and ground connections. There's also one that I think is negative 5 volts, this purple wire. Okay, that should be sufficient for us to take the power supply out. Now it has one of these big old British molded plugs on the end of the cable, and everything has to come through this hole. And I think the plug's going to need a little jiggery pokery to do that. But it's not too bad. There we go. Put the computer to one side while we work on the power supply. So unfortunately I didn't have the camera running for part of that, I now realize. So I've got the power supply out, and we can see that there's nice fresh electrolytic capacitors all over the board. So that's great. Like I said, I knew that this had been recapped, but it's nice to see the evidence of that. So the next thing I have to do is to take off, I've got to get this board out in order to be able to put in a new jumper down here. You can't quite see it under this quality control sticker, but there's a place here where I can put in a jumper to tell the power supply basically that it's or to set it to an input voltage of 120 rather than 240. But in order to do that, we need to pull the board out of this housing. And in order to do that, we need to disconnect it from this switch and put this auxiliary power, pull that through. So everything I've read suggests these are pretty difficult to get off, which did indeed seem to be the case when I was just trying to do that a minute ago. But there we go. With the aid of a flat blade screwdriver, it became a lot easier. Okay, put that over there. Let's just see. It's tricky to get in. You know what? I need some glasses on while I'm doing this. Okay, so with only a moderate amount of swearing, I managed to get this out, but we're okay with swearing. We're British. It's a British computer. I still don't have. I've also removed the two nuts, one at this end and one at that end, that connect the ground supplies, or not supplies, but the ground leads. Got to be careful because one of them has this little washer on it that it's easy to lose. I know because I did, and then managed to retrieve it again. Okay, so now there are just 3 screws, I believe, that are holding this board into this into the case. There's one here, there's one over here, and there's one down in here. And this one seems to have been hot glued in place, which is a little frustrating. So we're going to have to break that. And then I still haven't removed this. I removed the leads from this switch, but I haven't actually removed the switch. And so I'm still hoping that I can get into where I need to without removing the switch. But it might turn out that I need to remove the switch. So let's just see. Well, that turned out to be much easier than I thought. Where's the lens? The screw has hot glue on the screw, but the hot glue was not actually holding it onto the board. So that's clearly old hot glue that had been broken through already as part of the earlier repair that somebody did on this. Okay, let me put those screws somewhere safe, and then we'll see if I can slide the board out of the housing. Well, the switch is out. Lots of videos online that talk about doing this will tell you that that can be a little bit of a struggle. A bit of a struggle is the mildest way of describing what I went through to get this out. It's basically impossible to simultaneously almost impossible to get your fingers in there at all. But to get your fingers in there and to manipulate it and to see what you're doing are basically not things that can be done at the same time. And what's more, the plastic on the top, these lugs had sort of deformed. So I ended up having to cut those out. So we'll just see. I may have to end up hot gluing this back to make it stable when I put it back. I think it's going to be okay, but we'll see when I get to that point. But that means now that that's out, the board can come out. The board couldn't come out before that because there's a transformer here that wouldn't be able to get past that switch. This transformer couldn't get past the switch. So let's just pull this board out. Here we go. And then up here, you may be able to see I've taken away the sticker, the quality assurance sticker that was on there. But there's 3 holes here, and it's labeled so that if 2 of them are connected, then it's expecting an input voltage of about 230 volts. And if the other 2 are connected, it's expecting an input voltage half that, about 115. So that's what we need to bridge for the US voltage. So first I'll need to remove, there's a solder link that's on the other side that's linking these 2 holes. So I'll need to desolder that, and then I'll put in a wire to link the other 2 pins, to link so that we have a link going over to the 115. So let me get my soldering iron and we can get to work on that. Okay, so here we are. Here on the board this is the solder bridge that I've got to remove. That's currently telling it that its input value is 230 volts. And then that blob of solder and this one in the middle are the two that I will need to connect with a jumper wire in order to set it to 115 input voltage. So this is likely 40-year-old solder. It's probably going to take a little bit to get rid of it. I can add some more, but I'm going to start off by adding some flux. Get my solder sucker ready. Let's just see how we go. The short answer is that went better. I'm not finished by any means, but the solder actually melted. I think what I'm going to need to do is use solder braid to clean it up. So where did I put my solder braid? There it is. Looking at that, it still looks thoroughly connected, not in any way. It's like there's pads on there that are connected. Because these are both connected to the same trace, so there's no way to disconnect them entirely. But I think this is going to work. So it couldn't be a much easier fix. And it's kind of hilarious that all we have to do is make that bridge, and it takes 2 minutes, but the actual process of getting into the power supply took me a couple of hours, including some breaks for swearing. Okay, let me put everything back together again, and then we'll see how we're doing. I'm going to start off by putting it together and then just testing that the voltages we're getting out are approximately correct. Okay, it's time to see if it works. I've got it reassembled and everything is reconnected. I have it plugged in. Nothing's blown up so far. Nothing smells bad. Let's turn it on. Okay, and then if I set my multimeter here to DC voltage and just check on here. Trying to measure the 5-volt line. 5.063. Okay, that's a good sign. This one I think is the negative 5-volt line, but I'm not terribly sure. It might also be 12. Negative 5. Sorry, I'm just not making very good connections. I got a negative 5 point something. It says negative 4.01, but I think that's a poor connection I'm making. All right, I'm comfortable enough that that is correctly regulating from 120 volt supply. So that's good enough. That means I should be able to put it back into the computer, hook things up, and then we'll see if it's working. It's the following day. Everything's been reassembled, and a video cable has now arrived, so I can connect everything up. So let's just turn it on and see what happens. First, I'll power on the monitor, and then the computer. That's a very familiar sound. That's the sound of my childhood. And we've got the startup screen. So we're typing to basic. So it's working. That's very gratifying. I'm not going to show you very much about this computer just now because I've got a really crappy video setup and there's a better one coming. I'm just using a composite cable. Composite output from this computer is by default only black and white. There's a way I can modify it so I can get color composite out. But I've got a cable coming so that I can get RGB directly out and convert that to HDMI, or at least have a good go at that, which will let me capture it directly. And so we'll do I'll do more of an exploration of what it can do in some other video. But the basics of this for this video, which is just the power supply conversion, seems to have been successful. This computer now operates on American voltages, which is really just as well because I'm in America.